algebra students, we have been working with radicals and we've been doing mostly review. Today we're going to look at simplifying square roots that have radicands which have variables to powers. Remember that this is the radical sign and 64 is the radicand. Okay, just to make sure you have your terminology. We have the radical sign and the radicand. The radicand is the expression that is under the radical sign. So let's look at a simple example. Square roots like 10, the square root of 10 to the 4th, can be simplified using the product powers property. Remember the product of powers property, the product of powers property states that the square root of a product is equal to the product of the square roots of the factors. So the square root of 10 to the 4th can be written as the square root of the product of 10 squared times 10 squared, because 10 squared times 10 squared, those powers add, we go back to 10 to the 4th. And the square root of 10 squared times 10 squared is 10 squared. I'm going to show you two intermediate steps here, two ways that you could have done this. You can think of this as the square root of 10 squared times the square root of 10 squared, which of course the square root of 10 squared is 10, the square root of 10 squared is 10, and that equals 10 squared. So that's one way you could have done the intermediate steps that are not shown there. Another way is to think of this as the square root of 10 squared quantity squared, and the square root of anything squared is the base, which is 10 squared. So those intermediate steps were not shown there. You would have to go this way or that way. Now let's move on to the square root of even powers. For every number 2n, okay, 2n ensures that it's even. Any even number is divisible by 2. For any power that is 2n, the square root of a to the 2n is equal to a to the n times a to the n. These powers add, a to the n times a to the n is a to the 2n. So those are equivalent statements. And the square root of, the middle step here would be the square root of a n squared. And the square root of a to the n quantity squared is equal to a to the n. We need to assume that a is a positive number. Okay, this does not work if you have a negative number. Let's simplify this example. Let me move this up so you can see it better. The square root of 25a to the 8th times b to the 18th equals the square root of 25 times the square root of a to the 8th times the square root of b to the 18th. Square root of 25 is 5. Square root of a to the 8th is a to the 4th. And the square root of b to the 18th is b to the 9th. I did not show the intermediate steps there. You see that the powers cut in half when they're even. B to the 9th, b to the 18th is b to the 9th squared. And the square root of that is b to the 9th. Or you can think of it as b to the 9th times b to the 9th. Okay, let's move on to odd powers. Odd powers are a little bit different. Our odd power is going to be represented in the formula by 2n plus 1. So the square root of 2n plus 1, which is odd, needs to be thought of as an even power times a power of 1. The product here comes out to a to the 2n plus 1. Those powers add. We go back to the expression on the left. The square root of a, if we show the intermediate step, the square root of a to the 2n times a to the first is equal to a to the n times a, and there's your final answer. Let's look at an example. The square root of 28 x cubed y to the 7th power. I broke this into factors. 28 is 4 times 7. X cubed is x squared times x. Y to the 7th is y to the 6th times y. That's applying this rule. Now I've rearranged it to put the perfect squares more left and everything that's not a perfect square on the right. Seven, x, and y are not perfect squares, so they will remain under the radical sign. 4, x squared, and y to the 6th are all perfect squares. Square root of 4 is 2, the square root of x squared is x, the square root of y to the 6th is y cubed. These are not perfect squares, they will remain under the radical sign. This is now an exact simplification of that. We often do not want to estimate when we're doing math and science, and so we have to be able to express our answers precisely using radical terms that can't be simplified. Note that 4x squared and y to the 6th are perfect squares, and 7x and y are not. Couple simple examples to go through here. These we've done last week. The square root of 32. We're going to break that into the square root of 16 times 2, which is the square root of 16 times the square root of 2, which is 4 the square root of 2. 9x cubed is the same as the square root of 9 times x squared times x. We factored that using perfect square factors. Note that these two are perfect squares and the x is not. Break that apart. A and the square root of 9 is 3, the square root of x squared is x, and the square root of x cannot be simplified and it will remain as the square root of x. Now when you're doing your work for me, I'd like you for the first few to show this step, okay? It's not essential to show this step. It's good to show at least this step a few times until you really get your feet on the ground and get the hang of this and understand the concept. Okay, that's very important as you get into the harder ones. So show the work for several of them in the beginning. Eventually, after a lot of practice, you should be able to go from there to there. And that should be your goal. I'd like you to freeze the screen and work on those two, and I'm going to pop the answers up. And there are the answers. The square root of 24 equals 2 times the square root of 6. We worked on that in the last section. The square root of 25x squared is 5x. I want you to freeze your screen again. Here's a couple of simple ones. 32b, the square root of 32b to the 4th. And then we have a couple of harder ones here. Okay, I think you can read those. You may have printed out your handouts. I want you to work on those and freeze your screen, and I'm going to pop up the solutions to those. 32b to the 4th, 16 times 2b squared times b squared equals 4b squared times the square root of 2. This one, we're going to take the 45 over 5, since neither of them are perfect squares, but the quotient of it is, in that case, we're going to divide them. Sometimes you don't. Sometimes the numbers may be, one or two of the numbers may be a perfect square when you have a quotient, in which case you would not divide them. But here 45 over 5 is 9, and we get 9 m squared, m cubed over m is m squared, n squared over n to the 4th is n squared downstairs. And we're going to simplify that into 3. Square root of m squared is m, and the square root of n squared is n, and there's your final answer. Hope you did well on that one. The last one, a little bit trickier. Back to, we're not going to get away from it, perfect square trinomial. I hope you all saw that. Perfect square trinomial factors into a perfect square. I want to write it as the perfect square form so I can see very clearly that this is the square root of a perfect square. and the base is a minus 6, and that is that radical simplified. So there you go, have fun with that.